so many people floating into the room. Bonjour, Patrick. Everybody is on time here. Quite impressive.
So, 10 Uhr.
Yeah. In sake of the time and of the restricted time, I think we really should start on time, which is now. And to all those who have just joined or have joined since some minutes, we say hello. We from the Daccelerate team within the European Dac delivery program. The Dac is for Digital Automatic Coupler. We thank very much for your huge interest because we have a lot of registrations and participants today for this Dac Migration Workshop that will take place now between 10 o'clock now and lunchtime 12 o'clock. We have the following agenda for you. We have a challenge on migration, and later on the explanation how we came to the solution means feasibility of certain operations with the couplers, which leads then to migration strategies. Later on, after a short video, we have the implementation of the strategy with its different restrictions and challenges, and we close then with outlook and next steps. So what we present to you is the state of mid of this year plus recent developments which took place since the summer until now. This is the setting, and as you see, we will put all the questions at the end of the meeting that you might have, because it's very likely that many of your questions will be answered during the next sessions. My name is Jens Engelmann. I'm one of the two program managers of the Dac delivery program here all over Europe, and the other colleagues representing themselves will shortly say who they are, but in general we have here the domain players, which are Oliver Martin and Christian Kuhn and Andreas Lipka. Oliver Martin for Oak Tree Partners, Christian Kuhn for CK Rail and Logistics, as the consultants within the Daccelerate project that we had for funding these activities. And Andreas Lipka is the head of the work package migration within the EDTP. We have the kind support of Ivana Todt, hi Ivana, and Peter Perstel from Virtual Vehicle, and Peter will let us know a little bit about the technicalities of this meeting. And for this, I will hand over for a minute to Peter, and for any open potential questions, including registration of this video. And then I will start with a short introduction and hand over to the main actors here of this endeavor. We hope that this will be very insightful for you, that it will give you answers on things that you had maybe not yet had. You can collect the questions, but this is all that Peter will explain to you, how you can ask your questions, which we'll then hopefully answer at the end of the meeting. And by lunchtime, we hope that you go. I think this is also, Peter, one of the things that everybody has to be muted during the meeting. We will say it in a moment. And we hope that at lunchtime, you will go out and say, whoop, this looks really like an awesome work. And Peter, please let us know how it works in this meeting technically.
Okay, thank you very much, Jens, for your introduction and the words. As you can see on the slide already, there is the possibility to ask questions. There are more than 100 participants. Just for your interest, this is also going to be recorded. So if some of your colleague needs to watch it afterwards, you're gonna see the video afterwards. Just so you know, this is being recorded. If you want to ask questions, we have two possibilities. The first and the easiest is use Slido. So all you need to do is go on www.slido.com, join as a participant, use this number here, which you can see here, 3139536, and you're gonna get to a page, Slido, where you can basically ask your questions directly at this website. The other possibility is you have a button in the MS Teams, which is called Q&A, or in other languages probably different, but the question and answer button. And at the end of the session, you can also raise your hand and ask your questions directly. So we have basically 3 different ways of asking your questions. I would prefer Slido because I can see it on my screen next to me and also sort of go through the questions beforehand and collect the questions and cluster them, and you have also the possibility to use MS Teams. But this is pretty much it. And from a technical point of view, please mute your microphones. Maybe if you're not a presenter, also don't use the videos. And yeah, I think we're good to go from a technical point of view. Jens, so back to you, please.
Many thanks. Hope this is clear. And I have just one simple introductory slide. Because I will not explain to you now all why we have Dac and why we need Dac and so on. I think you have joined this meeting because you are interested in more specific information. But what is maybe interesting to make the link to the migration is the use cases, the different use cases, the functionalities that we want to implement with this digital and with the automatic and with the coupling. That means we have several areas from the pure, what you see on the left top here, from what you call core system, which is coupling and uncoupling, but also already some digital functions like recording of train composition, the remote uncoupling, automatic uncoupling, might be from the loco or might be from remote, which then helps in the areas also of shunting. You see on the right side, we have then more digital technologies like maybe parking brake, automated L valves, and some gadgets on top. We have, especially in the left lower part, train preparation with some of us call it killer applications like automatic brake test, where we really save a lot of time, and the basics for automatic technical wagon inspection and more benefits on the train run and so on. Why do I say that? Normally this should be known, but the interesting thing is that today a freight wagon consists of some tons of steel, maybe a little bit of rubber, and that's it. And the loco, at least the freight loco, consists of 2 buffers and a hook in the middle, so a UIC screw coupler, as the wagons do. And normally it has enough power to pull the train and to brake and to accelerate. The question, how do we all get this technology that we need into the vehicles? And you will see about how many vehicles we are talking in Europe. This is the real art, because it's easy to say with each new vehicle we buy the new components, and then it's like in a car, your next car has an even better navigation system or so, and you don't care about the old cars. What we here have to do is we have to transform a full system to make all these use cases function in a homogeneous way on more or less all vehicles concerned. And this brings you to a certain heartache situation. And the colleagues will now, Andreas will start with a challenge, show you from where we come, what we did to reflect on this, and how we would implement it in the whole fleet, so that we one day can see all these use cases functioning. That would be, I think, my fully sufficient introduction, and I hand over to Andreas and ready to rumble. Please go. Thank you.
Thank you very much, Jens. Jens was mentioning something about headache, so this is what's about it here today, and so you are right here for that topic. So the migration challenge is based on the thought to follow 2 general imperatives. Next slide, please, Peter. Thanks. The first you see on the left side with the 2 wagons, you see both coupler types are not compatible with each other, and that means we should avoid that they meet each other, at least based on a conceptual approach and or based on migration strategies. So we have to avoid that they are on the same track. Of course, there will be sooner or later during the migration period where a situation where a dispatcher makes a mistake, but in general we have to plan migration in the way that we prevent us from these situations. Second imperative that is guiding us through the whole migration planning and migration strategy discussion is on the bottom left, and this is the absence time of the vehicles from the customer. This should be as minimized as much as possible, and we believe that this is that crucial that everything else has to follow these two imperatives. This leads us to several fields of action. First is, of course, a group of different migration strategies. About them you will hear a lot of today, as well as retrofitting concepts and solutions or possible solutions for staff resources for the workshops. Migration planning is influencing the coupler design and things like procurement, funding programs, and of course there's the need for a European coordination to synchronize and to steer the migration, and not to make only nice plans but nobody is following them. So this will be, let's say, the general challenge that we are facing currently, and I'm very happy that within the last 12 months we developed in the team, and thanks again to the Daccelerate colleagues here, that we developed a lot of possible solutions. And next slide, please. Even knowing that for some of the vehicles, not only wagons but also locomotives, the both coupler types here on the left-hand side, the standard Scharfenberg design for a DAC or the hybrid coupler for the locomotives are technically not possible. For example, not all of the wagons have the frame stability needed for a central buffer coupler, or the locomotives have weight limitations, or the installation space is missing for such a device, and so on. So this is another challenge aside of the topic that they are not compatible with the screw coupler. Next one, please. But the concepts we developed together as a team, and in the European Duct Delivery Program we are currently more than 250 experts from more than 80 different companies, institutions, and authorities. We have represented here more than 30 European countries where the participants stem from. So this is all the development has been done on a very vast expertise all over Europe. We give you today an insight on what has been developed by the Daccelerate team and the colleagues from the migration work package from the EDDP, and I'd like to hand over now to Christian.
Thank you very much, Andreas, for this introduction to the challenge. I will indeed, for some minutes, continue with the challenges and boundary conditions and explain a little bit for the audience why migrating from a screw coupler system to an automated coupler system and a DAC system is not an easy challenge, but bear with me, we also come to the solution in a couple of minutes. First slide, please. What you can see here on this side, and it's going to be very, very brief, you can look at it later on in the presentation, is that the European rail freight transportation in its very core is truly an international business. One of the arguments we have heard several times, especially at the beginning of our discussions, was why don't we just migrate geographically? We start in some area and then slowly move on, and piece by piece the whole system will be migrated, and that shouldn't be so complicated. Well, the reality is that international flows in many, many countries account for more than 50% of the overall rail freight, and that the dependencies between countries are so strong that this, in our view, is not a feasible approach. You can define and show that there are some countries more to the periphery of Europe where a separate, earlier or later than the main system migration might be feasible, but I think it is important to understand as a starting point that we have to take this international dimension into account, and that national standalone solutions would normally not be a feasible way of getting from where we are today to the future world of automated couplers. Next slide, please. Let's now have a look in the principal, very much simplified ways of how freight trains operate in Europe, and it doesn't really depend on whether we're talking about wagon load at that point or intermodal. Of course, a significant part of the volumes are moving in relatively simple unit train moves from one siding or terminal.
I think.
Yeah, Christian, I think you tapped on your microphone. You are.
Hopefully not, but somebody has. Sorry.
Yeah,
Yes,
no, it's good. Okay.
Where did I lose you?
1 sentence ago.
1 sentence ago. So you can see that a significant part of European rail freight traffic is done by unit trains, moving from siding to siding or from terminal to terminal. A lot of the intermodal traffic works this way, at least at first glance. And this is, of course, the easiest to migrate type of flow. Then we have a little bit more complex flows where already wagon groups are being shunted around. Wagons might switch between different types of traffic. So there is some intermediate shunting involved between a first mile and the last mile sections. Of course, again, such systems can even be much more complicated, but for the sake of first analysis, let's keep it a little bit simple here. And then last but not least, of course, we have the wagon load system. We have called it here network trains. It is mostly single wagon load, but not only. And if you dive deeper into what the rail freight system looks like, especially in the core countries you have seen on the previous slide, you still come to the point that this single wagon load system is quite an important point and part of the overall setup. On the next slides, we are starting to look a little bit into the critical components. The movement of a train that has been formed on a railway line from A to B is of course not very critical. You either have it with automated coupler or you have it still with the screw coupler during a migration period. And you can even think of having a train that consists of 2 blocks or groups of wagons that are then being separated out. It gets completely different if we are going to the big marshalling yards, and studies have shown that big marshalling yards cannot operate with mixed coupler operations in a migration period. The exception is, of course, if we have a very small amount of wagons that have already been equipped with automated couplers, say something like 10%, such mixed operation is still feasible. And on the other hand, if we're having the contrary situation, most of the migration has been done. We still have a remaining 10 or 15% of wagons that have not been fitted with automated couplers. Then again, big marshalling yards might be able to operate. What we are showing here is one of the solutions discussed, meaning we're having mixed trains of Dac wagons and screw coupler wagons going in and out, and we have adapter wagons in between, the ones that are schematically shown white here. And we are practically pushing a train over the hill of a marshalling yard that consists of the 2 things, and we're forming new trains that in between every group or wagon with Dac and a group with screw couplers need to have adapter wagons. I think it becomes quite evident that first of all, we need a lot of adapter wagons. The logistics of these wagons will be a nightmare. Secondly, the pushing of the train over the hill has to be interrupted every so and so often because the adapter wagons need to be put in between the newly formed blocks on the receiving tracks. This is not a modus operandi of a big marshalling yard that can at any place work for any sustained period of time, because the capacity of both the receiving tracks and the hill will simply not be enough to handle the current traffic volumes. Doubling the system is also not an option. A, we do not have 2 marshalling yards in each and every location, and B, of course, the cost of such an operation would be prohibitive. I will at that point, for the sake of time, not go into the details of alternative strategies. There are 2 or 3 more strategies that have been tested on how to run a marshalling yard in a mixed coupler environment. Believe me, they are all not working. Next slide, please. Another complication, which is a little bit of a different nature, are the big customer sidings, terminals, industrial areas, and similar. We have been looking into a number of such areas in the studies, and we've picked out one of the areas here just for illustration. And that shows you that even if we are able to separate DAC operations from screw coupler operations on the mainline network, we have a lot of terminal areas where flows from various operators from various systems come together and will then still result in very complicated settings. This is just one example, a fluvial port in the Düsseldorf area that shows you how many different important customers can sit on the same sidings. And if you imagine that a part of the flows going in and out of such a terminal environment are already migrated to DAC and others are not, you can imagine the challenge that the operator of such a terminal facility will have to face for an intermediate period. In migration, to be very clear, we will not be able to avoid such mixed setups, but we should bear in mind that they will ultimately complicate operations, planning and operations in the migration period, which is another argument in favor of keeping this migration period to a very, very short length and time. Next slide, please. A little look into how wagon load systems and networks typically operate and how they are structured from a demand perspective. Another argument we have heard several times is, oh, why don't we just take out the most important flows and migrate them to DAC and the rest will sort of take care of itself? Or isn't there a possibility to cut these wagon load systems potentially even dynamically into parts that are then migrated on a case-by-case basis? Well, again, it leads us back to the previous conclusions. It will be potentially the customer terminals, but more importantly, the big and small shunting yards that will be overwhelmed by such a strategy. Again, you are seeing here in blue the initial starting point of the operation. This is a simulation which was conducted by DB Cargo some months ago. You start with a blue system where all the wagons in the systems are screw couplers. Then at the end stage, which would be green, it's not shown here, everything would be migrated to DAC, and the red buttons in between show the shunting yards while they're operating with anything between 20 and 80% screw couplers and the rest being already DAC. The problem is that in a successive continuous migration over 6 years, this is the modeling that we have seen here, the simulation results, in a long period in the middle of the migration, you're practically overwhelming almost all the marshalling and shunting yards with percentages of mix between screw coupler and DAC that are not sustainable and will practically not be possible to operate. The traffic concentration in the European system, and we believe that DP is pretty much representative for other situations as well, is such that a lot of the potential connections between points in the matrix, like all the points in the network you connect, are effectively also used. About half of the possible connections in such a wagon load system actually exist with traffic flows. So the system is highly interlinked, and we do not believe that it will be possible, neither from a planning nor from operations perspective, to separate the flows in a way that migration could work in a mixed coupler environment. So the short message here is that we believe that the core of the European system, the network traffic, cannot be migrated over a longer period of time and operated with mixed couplers. Next slide, please. This is why we suggest to look at the rail traffic in Europe for the purpose of migration with two different systems. One part of the systems, which we call here the non-CWS. CWS stands for the core wagon load system, where most of the wagon load flows and a lot of the supporting flows are being operated. The non-core wagon load system parts, meaning unit trains that have a clear separation of the wagons, between a pair of origin and destination. The easiest case, loaded wagons go one way, loaded wagons come either back or go back empty. These flows are relatively easy to migrate. You can go on a case-by-case basis, and the terminals will need to live for a certain period of time with the challenges of mixed operations mentioned before. The second type of trains are still unit trains with fixed wagon sets, but they are being switched between different pairs of origin destination. A little bit more challenging because, of course, you're not limited just to two places where the train sets go to and come from, but you will need to deal with a bigger amount of such places. Still, we believe that handling this situation can be done over time, and you can accept a certain amount of mixed coupler operations in such a system. The third system where we still do believe that separation is possible are wagon group systems that are being shunted intermediate on the way. Maybe wagon groups between various trains are being exchanged, but as long as these wagon group systems have a dedicated fleet of wagons that can be separated from the rest of the system, such systems also can be migrated separately. We indeed have a good example. SBB Cargo's pilot traffic for digital automated coupler in Switzerland is a national system that consists of wagon group and does exactly this. The main challenge for the first three types of traffic are, of course, the dispatch of damaged wagons to workshop. In this case, also today, the general wagon load system is being used, but we do believe that for intermediate period, solutions can be found by sending these wagons to workshops that are in proximity to the traffic concerned, and or by sending them through the general wagon load system using adapter wagons for an intermediate period of time. That will not bring the overall big system to a point of collapsing that we have discussed before. The main challenge for migration, of course, sits in the second group of flows, meaning firstly, still unit trains. You look at them, think this is a unit train, this should be easy, but there are cases where the empty wagons are not being transported back in another unit train going back to a point of expedition, but they are going back in the general wagon load system. So the wagons need to be compatible with that general wagon load system. Of course, similar logic applies to the single wagon load system being used for the dispatch of empties in wagon load systems. So wagon load systems that do not have a dedicated fleet. And we believe the majority of the wagon load systems are being worked out this way. And the last one is the general single wagon load that, of course, is very much the backbone and core of this system. And that, again, for the links that we've shown before, needs to be migrated as one big system and not in different small entities. Let me give you a little bit of numbers to conclude this chapter. Next slide, please. Of course, one of the questions that you should believe is easy to answer, but in reality it's not as easy as one would hope, is the question, how many freight wagons are we looking at in total? And you may have heard a lot of numbers. We have done quite extensive analysis to try to determine how big the fleet is in reality that we need to look at for migrating the freight traffic in Europe. So, for example, there are a lot of rail wagons that are very scarcely used, a lot of rail wagons that are used only for maintaining the railway infrastructure. We have not looked at these wagons for the sake of the migration simulation because we wanted to limit the fleet to something that is still possible to handle. To our best belief, we're talking about roughly 460,000 freight wagons that will need to be migrated. And out of these 460,000, roughly 210,000, following our analysis, are essentially being used in the core wagon load systems and cannot be migrated out and migrated separately over time on a case-by-case basis. This, of course, is an estimation that has certain amounts of uncertainty in it, as the numbers suggest. But I think it is important to understand the dimensioning and the order of magnitude of the migration challenge, especially when it comes to the core system. So this is a lot of preliminary information that I think is important to have as a starting point for the migration strategy, which will tell you a little bit on how we suggest to then handle this transition from the screw coupling system to the Dac. And with that, I'd hand over to my colleague Oliver for the next part of this session.
Thank you, Christian. So let's have a look at the migration strategies that are feasible and that take the boundaries of that Christian has just explained into account. Next slide, please. We'll start with the non-core wagon load system. So the three types of flows which you had just seen on the previous slide. No, that should actually be a previous one. I don't know. Got lost. Next one, please. Okay, so let's start out with this one. Let's have a look at the non-core wagon load system and at the migration of individual flows within this system. There are basically three ways how to migrate the system. It can be done step by step, as Christian has explained, per OD. And you can either migrate the entire train consist in one single step migration. And this is here the left case where the screw coupler in blue on the top, will be migrated to a Dac train set, for example, over a weekend, if you have a lot of migration capacity available. The second way to migrate these flows might be also in several pieces or chunks, and that can be done if you have the availability of an adapter wagon, which is here the wagon in the middle, which on the one side has a blue screw coupler and on the other side an orange Dac already. And so you can operate this train set, with a screw coupler and with a Dac block. And then there is one very peculiar case, which is the case on the right. This is a train set which in principle has been migrated, in a single step towards an entire Dac train set. But in order to be flexible in terms of the locomotive to be used, we have kept at one end of the train set two adapter wagons, which have a Dac on one side and screw coupler on the other side. And you see that by shunting the last or the first wagon towards the last position, in effect, the train set can be moved from a Dac train set towards a screw coupler train set. Yeah? And these three principal migration strategies can then be used on individual ODs, and therefore the entire system can be migrated step by step. So previous slide then, please, I guess. Let's have a look at the bigger problem, which is the core wagon load system, as Christian has just explained. We have learned that we actually need to convert the core wagon load system in one piece, since we cannot cut it into pieces, and mixed operations in marshalling yards and larger customer sidings, will not be feasible for a prolonged period of time. And therefore, the only strategy that is available is to convert the system in one step. And in order not to lose capacity in customers over a long period of time, a long conversion period, we actually need to do it in a very short period of time, ideally 2 weeks or less. The 2 weeks, which we name here, are basically driven from the potential downtime, for that a normal average customer is able to bear. But of course, there are also certain industries like process industries that are dependent on a rail service every day. And so when we talk here about a Big Bang, we basically do not mean to stop the entire system, but to cut it down as much as possible. So the Big Bang means we will convert the entire system, or we will have to convert the entire system in a very short time. And the time period until the Big Bang will start, the entire core wagon load system will be operated in a screw coupler only mode. And after Big Bang, the entire system will be operated in the Dac only mode. Why is that the case, or why do we need to make that happen? We need to make that happen in order to operate efficient systems. If we keep screw coupler wagons in the big core wagon load system, also after the Big Bang, that means that certain resources like shunters, etc., will still need to be kept, and efficiencies cannot be gained by the RUs. Now, of course, this is a big challenge. We have 210,000 wagons, that need to be converted in a very short time frame, and that will not be possible without certain tricks. We have invented 3 tricks to make that feasible. Before I get into these tricks, let me briefly also explain that, of course, prior to the Big Bang, the entire locomotive fleet will need to be converted to hybrid couplers, so that after the Big Bang has happened, the locomotive fleet is ready to also operate in the Dac mode. Next page, no, 2 pages further, please. Okay, so our first trick we call the 3-step technical migration logic. Sounds very complicated. What is the reasoning behind this trick? It's very simple. We actually try to minimize the retrofit activity that will need to happen during the Big Bang itself. So we try to prepare the wagons to the maximal amount possible to make the Big Bang as simple as possible. And we do that by creating or by converting the wagons to a state that we call Dac ready preparation. And Dac ready preparation in principle consists of 2 steps. Step number 1 is that the suspension package of the screw coupler needs to be exchanged by a new suspension package. In order to do so, the wagon will need to be lifted, and that can only be done in workshops. And so we actually want to use planned maintenance slots for this conversion. After the retrofitting of the suspension package, we can actually fit back on the old screw coupler, since the interface between the coupler head and the suspension package is standardized, and it's basically the same standard for screw coupler and for Dac. And that means that after the Dac ready preparation, the wagon will keep its screw coupler head. In this phase also, the D equipment will be fitted to the maximum amount possible, and also some piping for the brake pipes will need to be adjusted. Now, with that preparation, we can actually do the conversion to a Dac type 2 level in the second step quite easily, because it can be done close to customers or close to big marshalling yards or shunting yards. We will not be needing any wagon maintenance workshops anymore. The wagon will not need to be lifted anymore, but the standard pin will need to be pulled underneath the wagon. The screw coupler head will be taken off, and the Dac head will be put on, and the buffers will be removed. And so this is a rather simple procedure that can also be done by untrained or at least not fully trained personnel, and which allows us to expand capacity for this conversion by doing such a conversion in mobile retrofit centers, which we call here vaccination centers. The wagon will leave this second retrofit step with a Dac type 2 use level, as we call it. So the wagon will only be used as Dac type 2, not a higher type, for the reason that we need to minimize the risk of retrofitting in the second step. Imagine there will be 200,000 wagons retrofitted, and we won't have a huge test run before. And so this will be basically one big conversion. When we're in the middle of the conversion and we actually see that some certain technical aspects do not work as planned, the entire system will be ruined because we cannot turn it back. And so we actually will migrate to the minimum Dac type level that can be used for operations. After this second step, there will be a third step, which is now here called the Dac type 4+. So 4+ means 4 or 5 upgrade. And that means after the Big Bang has happened and after we have been successful the full functionality of the Dac can then be switched on in principle. So this is our first trick. Next page, please. The second trick.
I just pop in and ask a question, Lohmeier from Knorr-Bremse, about the previous slide. So what kind of use case levels then from the very first slide that Mr. Engelmann showed are addressed in that type 2 usage? Because you have the...
Sorry, could we limit the questions to the end of the presentation?
Okay.
For the sake of time management.
Okay.
It was at the beginning.
It's noted. Yeah, we will come back to that because it's an important question, and I think others will also ask that. I have noted it down. Yeah. Okay.
Okay.
Thank you.
So I think I won't answer the question, but our primary concern here in developing the strategy, first of all, has been to find a path to do the migration at all. Yeah, of course, from an economic perspective, switching on the 4 and 5 functionality as early as possible would be advised. Now, coming to our second strategy, which is the so-called fixed wagon pair strategy. So, still the conversion of 200,000 wagons, within 2 weeks, even though we do it in 3 steps, is still a huge task. And so in order to further limit the need for maintenance personnel during the Big Bang, we have developed this strategy here in a workshop, and which basically means that prior to the Big Bang, we create fixed wagon pairs. These are wagon pairs which operationally cannot be separated anymore after the inner part of this wagon pair is converted to Dac. So you see the wagon pair has still the screw coupler on the outside, and on the inside it's a Dac. And from that point on, these wagons will only will operate as one virtual wagon, so to say, in the system. This actually has a benefit that during Big Bang, this wagon pair will not need any more maintenance or retrofit activity, but instead we can basically switch it around, which means that the screw coupler is now on the inside and the Dac is on the outside. And in effect, without using maintenance personnel, we now have a virtual wagon with a Dac, and which can then be uncoupled post the Big Bang by also fitting 2 Dac coupler heads at the inner part of this wagon pair. And so by doing this, we can actually spread workload from the Big Bang to phases prior to the Big Bang or post Big Bang. It is also clear that this strategy cannot be used on the entire fleet because there are certain customers, which will not be able to use fixed wagon pairs, but we actually expect that this strategy can be used for quite some substantial share of the entire core wagon load system. Next page, please. There is one last strategy which we also want to use in order to optimize the workload during Big Bang further. And this is also a rather simple idea. We have explained to you that the wagons within the non-core wagon load system can be migrated prior to the Big Bang. And so what we do here is we convert a train consists outside the core wagon load system to Dac prior to the Big Bang. And then at the moment of the Big Bang, we will actually move these wagons into the core wagon load system and take screw coupler wagons, the same amount of screw coupler wagons from the core wagon load system, and move them into the non-core wagon load system. And so this is again just an operational trick. So in order to enhance the number of Dac wagons at the time of Big Bang without the need of any further maintenance activity. By doing that, and of course we can only do that for fleets which are being used in the non-core wagon load system and in the core wagon load system, because these wagon types need to be identical. So that in effect, then post Big Bang, we can actually do another conversion of the train set, which we have moved outside of the core wagon load system, and then we're done. So, and in effect, there is no maintenance, no retrofit activity in the Big Bang. There is one fourth strategy for which we have not created a separate chart, which would mean to produce Dac wagons here in higher amounts than the normal replacement rate prior to the Big Bang, and then move these new wagons into the system at the time of Big Bang. However, we are afraid that this lever cannot be pulled to a substantial amount, as it's first of all extremely expensive, and secondly also the industry capacity for the production of wagons is limited. Okay, next page. Christian. Your mic is out.
You would be much more fascinating with the voice on.
You don't read from my lips. Thank you for reminding me. Before we move into even more technical detail, as a little bit of a breaking point between session 1 and 2, we have actually, or we have planned to insert a video that was generated and produced this summer by Deutsche Bahn for one of the tricks that Oliver has just explained, and Andreas and his teams with colleagues have tried it out. So just have a little look on how things could be done in the future before I continue.
Give me a quick second, I'll just share the video.
Bartek, bitte. Yes. Ja. Was ist? Mir ist gesagt worden, das ist in der Dings sogar drinnen, im Grenzübereinkommen, glaube ich sogar.
Hier wird durchs Mikrofon.
Heute ist der Schienengüterverkehr im Prinzip so, wie unsere Urgroßväter ihn vor 150 Jahren erfunden haben.
Peter, I hear a voice, but I don't see a video.
Yeah, there is no movie.
Die digitale automatische Kupplung macht den
Just give me a second, we'll be there in a second. Just need to restart it because it went in the background. Sorry.
Even with the best testing, you see, if you want to migrate electronics, you always run into
but
trouble.
it's more delayed.
Sound was already there.
There you go.
Heute ist der Schienengüterverkehr im Prinzip so, wie unsere Urgroßväter ihn vor 150 Jahren erfunden haben. Wir müssen unbedingt den Schienengüterverkehr digitalisieren und automatisieren. Die digitale automatische Kupplung macht den Schienengüterverkehr schneller, effizienter und einfacher. Um die digitale automatische Kupplung in ganz Europa einzuführen, müssen 500.000 Wagen umgerüstet werden. Diese Kupplung passt nicht zu den Schraubenkupplungen, die wir heute an den Güterwagen haben. Deswegen müssen wir Ideen haben, wie diese Fahrzeuge sich nicht begegnen, wie mit der neuen und mit der alten Kupplung. Und diese 500.000 Wagen können wir auch nicht vom Kunden wegnehmen. Eine der Ideen, die wir haben, ist die sogenannte Pop-up-Werkstatt. Die Pop-up-Werkstatt funktioniert so, dass wir nahe am Kunden auf einem Gleis wie heute hier ein Zelt hinstellen, Handwerker holen und die Güterwagen, die beim Kunden im Einsatz sind, kurz in die Pop-up-Werkstatt bringen, umrüsten auf die neue Kupplung und dann dem Kunden wieder zur Verfügung stellen. Und damit das möglichst schnell geht, haben wir die Wagen vorgerüstet. Vorrüsten heißt, wir bringen alles an dem Wagen an, was man für die DAK braucht, was aber im Betrieb mit der alten Kupplung nicht stört. Das nennen wir machen den Wagen Dac Ready. In der Pop-up-Werkstatt haben wir die Puffer entfernt, wir haben den alten Zughaken rausgenommen, haben mit einem Gabelstapler die neue Kupplung reingeschoben, den Wagen nochmal getestet und jetzt geht er wieder auf die Reise. Bei dem Betriebsversuch haben wir viel gelernt. Die Pop-up-Werkstatt funktioniert, die Idee Dac Ready funktioniert auch. Jetzt verfeinern wir die Planungen und gehen die nächsten Schritte an.
Okay, so let's move back to the presentation. Perfect. That was a very nice video, and I think we all of us who are presenting here as part of the Daxcelerate team take some pride in the fact that an idea that was generated at a site visit in the Mannheim workshop of Deutsche Bahn back about a year ago. I think we were in November or December last year in Mannheim all together, crawling under the wagons, thinking about what we could do and how we could make this happen quicker and easier, has actually been demonstrated less than a year later by Deutsche Bahn in, I think, a customer sighting in Bremen. So it's fun to look at that. The next page actually does nothing else but to summarize some of the main components. And if you look at the wording, this is an older slide. It even says demonstration and testing planned for this summer at DB Cargo. Well, it has been done. And I think it's a great success to see that these things are not only working on slides and PowerPoint, but they can also actually work in reality, which is, of course, super important, because the feasibility of a Big Bang stands and falls with the feasibility of such pop-up workshop places, because the sheer amount of wagons that need to be converted in a very, very short amount of time is almost overwhelming if you start to discuss with people from the workshop environment. And we really strongly believe that this solution that has been demonstrated is at the very core of the feasibility of the entire migration. Next slide, please. A little bit back to numbers. And I am limiting myself to the two most critical aspects of migrating vehicles. There are many more aspects technically to migration, but the two ones that will effectively determine the capacity by our best knowledge of today are, on the one hand, the retrofitting of the wagons, and on the second part, the retrofitting of the locomotives. Let's stick to the wagons for a second, because there are many more in terms of numbers, but of course a little less than the complexity of the locomotive. Going back to the full conversion of an existing freight wagon into to Dac, to the digital automated coupler, we have quite, I would say, substantiated knowledge about the amount of labor hours needed to convert one wagon fully from screw couplers to Dac, including all the preparatory work. As a reminder, the preparatory work that is included in the figures you see here will of course be done before the Big Bang, and the wagons will be made Dac ready to then quickly be retrofitted in the vaccination centers and the mobile pop-up workshops that you have just seen in the video. The overall amount of time needed for converting a wagon of a standard type is around 26 hours, based on the real-time experiences of workshops in Germany and Switzerland that have done this conversion. And some of the time units or times required in here are not even fully taken into account, because they're very different from wagon to wagon. The second part, and that goes a little bit back to the question that was raised in the meantime, is even more difficult to answer, because there are not really many real-time experiences existing as of now. And that is the addition of all the electronics and data functions into the wagons. Mounting them, of course, is one challenge, but getting them into operations, testing them, and then releasing them, especially for safety critical components, into service is, of course, the second big questions. This is why you see the estimates for the time needs in here, just in very rough terms. So the preparation and mounting of the digital component will be an extremely critical element, and you'll see this when we get to the timing simulation and scenario simulations a little later, why this is so critical. Current estimates are around another 25 hours for putting in the main digitalized components. But as I have said, there is still a very high amount of uncertainty. We have had some experiences, some return of experiences from Swiss railways that have mounted their automated brake systems, and the need for that system was around 25 hours. As you have seen in Jens's introduction, there are many more ideas of what to put on a wagon, and putting them on the wagon, mounting it, and then putting it into service might even require higher amounts of time, which will be a challenge for the workshop capacities in Europe. Freight wagon workshops are limited in their availability, and they are already under stress for recruiting personnel and replacing existing personnel. That is a challenge across many industries in Europe, but railways are not exempt from the challenge. So trying to minimize these times will be something that the further development of the DAC and technical specifications and the detailing should take into account. Let's move to locomotives for a second. Next slide, please. Another challenge. If you look at the overall locomotive fleet associated with freight traffic in Europe, you find out that we're talking roughly about 20,000 locomotives across the countries concerned. Of course, most of the traffic on the longer distances is handled by electric locomotives, electric mainline locomotives. This is what you normally associate with freight traffic, and this is what you normally see. But of course, the reality is a bit more complex, because roughly half of the locomotives used in European freight tracks are diesel shunting locomotives. Less visible, many of them are in customer sidings or just at local stations, but they are an integral part of the service provision. While the electric mainline locomotives, as you can see here on this slide on the left-hand side, have quite, I would say, an equal sustainable distribution over age, and there has been continuous investment, you can effectively see that the investment into diesel mainline and shunting locomotives has been very, very limited, and indeed more than half.
Oliver, die hat Zeit und die will irgendwie gerne Gas geben.
Would you mind to switch off? I don't know who it is to switch off microphones. Somebody is not muted here. Thank you. So you can see that more than half of the fleet of the diesel locomotives in Europe is more than 50%, is more than 20 years old, and this will certainly provide quite a big challenge, especially if you think of the cost of retrofitting as opposed to the residual value of the locomotives concerned. The other aspect is that for the locomotives, next slide please, there has never been a unified norm, as there was for the wagons, for providing a unified installation space. And this, as we know, will lead to a much more complex situation as to the possibility of building in a DAC design into an existing locomotive. Challenges there go very much into detail. It's not only the availability of space in the locomotive for putting in the changed coupler and suspension elements, but it is also the ability of the locomotive frame to take the forces, the longitudinal pressure into the locomotive frame, which will not come through the buffers, but come at a central point into the locomotive frame. I will not bore you with too many technical details, but the knowledge about whether or not a particular kind of locomotive can be retrofitted with DAC is still quite limited. We do have a more or less reliable idea about the wagons, but we do not have a very reliable idea about the possibility of retrofitting locomotives. What you see here, the pie charts, are nothing else but a very rough estimate of the likely possibility to retrofit. There are many caveats to be made, especially as we know that a significant part of these locomotives should ideally be retrofitted not only with DAC, but should be retrofitted with a hybrid DAC, enabling them to move with both DAC wagons as well as, for an intermediate period, screw coupler wagons. It's very likely that for many of the local shunting and maybe even mainline diesel locomotives, we will need local adapter wagons, because those shunting locomotives either cannot be retrofitted at all to DAC with any reasonable effort, or the retrofitting to DAC of the old locomotives will simply not be viable from a commercial or financial perspective. So the best guess is that we will need to have a significant amount of those adapter wagons stationed in localities awaiting a replacement of the old shunting fleet. There are also some possibilities about having manual small adapters Some of you might know that the Scharfenberg coupler design, which is basically what is also being suggested for Dac, has such options. There are intermediate couplers for mere shunting purposes, but the forces that can be transmitted through these manual adapters are quite limited. So they will probably only be usable in workshop environments or in environments where just a very, very few wagons need to be shunted. They are not usable for movement of trains on a main line, and they are most likely also not be usable for the shunting of entire train sets or higher weights in a customer siding. Well, this is it on the retrofit capacities. Of course, there is much more analysis available also about the capacities of the industry to provide and produce the new couplers and so on and so forth. But we did not want to bore you with too many numbers and also manage time a little bit. And that's the point where I am handing over again to Oliver for leading us through the migration scenarios before we come to the conclusion and the opening of the discussion.
Thank you, Christian. Yeah, so Christian just mentioned it. We had the objective or the task to analyze the resource need for migration in order to assess its feasibility. Yeah, and so before I lead you through the scenarios, let's have a look at the next page first, in which we now summarized the principal migration strategy. We have two segments, the non-core wagon load system segment here on the top left. And this can be migrated in a series of individual subnetwork retrofits. And in effect, what you see here are these little step curves, and the number of Dac wagons will increase step by step over a prolonged period of time. And as the number of Dac wagons is rising, the number of screw coupler wagons will be shrinking towards a number that in the end will be non-zero. And why that is non-zero, I will explain in a bit. Secondly, on the left bottom, you see the core wagon load system. And here we have an entire different situation. As we have explained, the Big Bang is the only option to migrate the system without loss of massive loss of volume. And therefore, here we will have the preparation phase in which the locomotives will be converted and in which the wagon fleet will be made Dac ready. And then we have the Big Bang per se, and then we have the post-Big Bang phase. The Big Bang will only be a few weeks. Yeah? And so you see we have here a sharp decline in the screw coupler wagons and a sharp increase in the Dac wagons. And there won't be any screw coupler wagons left in the system after the Big Bang. Yeah? In order to realize the benefits of the Dac. So if we now overlay both these migration paths, then we get something that you see here on the right, which is the resulting overall. And so you see that, leading up to the Big Bang, the share of Dac wagons will increase. Then we will have a step function at the time of Big Bang, and then the stepwise increase towards 100% or close to 100% conversion of Dac will remain. However, as you know, some wagons actually cannot be converted to Dac, and these wagons will in effect need to be used continuously then outside of the core wagon load system. They can still continue to be used in individual client transports, similar to certain traffics using automated couplings, that we have in the system currently. Examples are certain iron ore transports, for example, from the Netherlands, towards Dillingerhütte or so, where, for example, DP is using automatic couplers. So this is the overall, scenario. And now we wanted to study the numbers and figures and see, how fast, can we actually migrate towards the Dac system. And in order to do so, we have developed three scenarios, which we see on the next page. The three scenarios start with a 4 + 2 year migration as scenario A. 4 + 2 years means that after 4 years, there will be the Big Bang, and then there will be further 2 years in order to complete the migration. And this scenario is basically the one that has been fitted to sector timing aspirations as they were expressed at the beginning of our study. Secondly, we have a scenario which we called the 6+3 year migration scenario, so which is 50% longer in time. And this scenario we have come up with because the 6 years leading up to the Big Bang is actually in sync with the standard Wagon revision cycle. That means that the Dac ready retrofit can be done without any substantial loss in Wagon capacity in the system. And then lastly, just out of interest, we also had a 4+8 year migration scenario, which also could be replaced probably by a more beneficial 6+6 year migration scenario in order to keep in sync with the standard Wagon revision cycle. That is a scenario that is clearly, in terms of sector aspirations, way too long, but which we were asked also to study. So our first question actually was the question: how much more capacity, personnel capacity, do we need in the Wagon maintenance workshops? And this question is answered on the next page. Okay, and so how to read this page? You see on the top, we have the 3 scenarios, A, B, and C. And the first figure which we show here is the required number of destination centers. In all 3 scenarios, the number of destination centers is the same, and it is driven by the Big Bang and the Big Bang fleet that needs to be converted, within the same 2 weeks of the Big Bang. We need around about 150 destination centers, where each of these destination centers should be operated 24/7 and have 6 wagon positions. So basically 6 wagons can be converted at the same time. For these destination centers, we actually would need an additional roughly 8,000 people strong workforce. And this workforce, as I mentioned before, does not need to be the most skilled workforce, because you've seen the work that has to be done is basically unscrewing and screwing stuff on, removing the coupler head and removing the buffers. And so that also can be done by shortly trained people. Yeah? But of course, this workforce also needs to have qualified oversight, by properly trained people. And so that's a challenge per se. That challenge, as I mentioned, is the same in all scenarios. Secondly, we have then studied how many more people here, which you see here expressed in percent of today's workforce, we need in the European wagon workshops. And as you can see here, we have always given 2 bars. One bar is pre-Big Bang, and the right bar is always post-Big Bang. What you can see from the figures here is that the figures depend heavily on the migration timing, and they depend heavily on the requirements for the D retrofit, which is as to now unknown, since also the D standard has not been defined yet. Our realistic assumption, taken from the Swiss experience, with which was explained by Christian a while ago, was 25 labor hours. So that are the numbers which you see here in the middle. And so if you look at these, then it becomes clear that within the 4+2 year migration scenario, we would roughly need 40% more personnel in the wagon workshops over the entire time period of these 6 years. So this is actually quite substantial. In the scenario C, that figure goes down to roughly 20% if we would go to the 6+6 year migration scenario. And both figures correspond to roughly 2,600 people, in the scenario A, or 1,700 people in scenario C. And so, in effect, that's actually quite substantial, although it does not, look so substantial. If you look at the workforce and at the current trends that you see in the RU and maintenance workshops, then you can actually see that we have a substantial problem here. The IUs expect a retirement wave until 2030. So roughly 50% of the workforce, will need to be exchanged by new personnel. And this new personnel, specifically here for Dac, does not only need to be, the normal fitters and welders, but we need electricians and mechatronics in order to also maintain and equip the D package. And so overall, that's quite a substantial challenge for the sector. And the availability of this adequate labor is basically then in the end determining the potential migration speed. I don't have a glass ball, so I cannot tell you, what the sector will be able to do. But very clearly, scenario A is a massive, massive challenge. We have also analyzed the wagon structure. Next page, please. Wagon fleet structure over the period of the migration. And you can clearly see that here on this page. And if you, we have 3 or 4 colors. The dark blue is the screw coupler. That's the share of screw coupler wagons in the system. The grayish color, this is Dac ready. Light blue is Dac type 2. And the normal, the yellow is Dac type 2. And the orange is Dac type 4+. And so you can see here, in scenario A, that at the time of the Big Bang, after 4 years, the number of yellow and orange wagons is increasing sharply. So this is a Big Bang effect. And then, it's increasing steadily towards something like 90%. And the remaining blue wagons is then, the share of fleet that cannot be equipped with Dac. And so a similar pattern you can also see here for the other scenarios B and C. And if you look at the evaluation of these 3 scenarios, then very clearly scenario A is the preferred one, as it is fast and meeting the political demands. However, as we have just explained, it goes hand in hand with the high demand of workshop capacity in terms of personnel. And another downside is that we need a significant number of extra workshop visits in the first 4 years in order to make the entire wagon fleet, Dac ready, since it's not in line with the normal revision cycle of the wagons. That's a benefit of scenario B, which is longer, 3 years longer. Here we don't have an impact of the wagon capacity due to the Dac ready retrofit. We have lower demand for workers in the wagon workshops, but however, this scenario does not meet the political requirements in terms of migration speed. And in terms of timing, scenario C is very slow, beyond the required migration speed of the sector. But it's the most realistic scenario in terms of additional labor need that is needed in the workshops. Next page, please. We have also had a look at the locomotives, and for the locomotives, you see similar pictures. The loco migration, as far as possible, will be completed until the time of the Big Bang. And during in all these scenarios, the retrofitting of the locomotives will actually not be an issue during the migration, because other than for wagons, the locomotive workshops have ample capacity. An individual locomotive has to be maintained much more often than a normal usual wagon. So that means that the retrofit of a locomotive takes up a much smaller time or percentage of the annual maintenance hours in such a workshop, which means that retrofit capacity in locomotive workshops will not be an issue at all. However, the main and the critical issue in locomotive migration is actually before the migration start, because as Christian has just explained, we have a high variety of locomotives and many very old locomotives with uncertain retrofitability, and actually need lots of engineering in order to ensure that these locomotives can be retrofitted. And this is therefore also a wonderful opportunity for the sector to collaborate and to exchange experience and pool resources in order to do these required analysis. Next page, please. Lastly, a quick look on the required component production needs. Here you see the various types of lines which are representing the different components needed, from suspension packages, coupler heads, hybrid coupler heads, certain special coupler solutions, by which we mean here solutions for wagons that cannot take the normal Dac solution, but will need to have a special solution. And you can see that no matter at which type of resource or component you're looking here, that the indicated capacity by the industry, which is the black line, in principle is sufficient in order to do the migration in all three scenarios. Care must be taken, however, to be ready at year one of the migration and to have sufficient component availability at the start of the migration cycle in order not to lose time. Okay, next page, please. So let's talk about risk. Unfortunately, we have not found any other way to migrate the system than in a Big Bang. This is just due to the fact, in order to remind you again, that the system cannot be cut into pieces and cannot be migrated in pieces, the core wagon load system. And so the overall migration scheme, which we present here, therefore actually comes with quite some substantial risks, starting from technical risks to timing risks of the migration start. Just an example, we don't only need the technical solution in order to start the migration. We also need money. We need the people in the workshops. These people need to be trained. We also need to have IT systems that are ready to, use the Dac or accommodate the Dac. And we also need to be able, for example, to operate the fixed wagon pairs, etc., etc. Yeah, so there are actually, quite a significant number of prerequisites that need to be established to only start the migration. We have seen that we have substantial risk in the timing of the migration duration, which is largely also connected to the available resources in the wagon workshops. And of course, we have organizational risk of the Big Bang. And I will explain that in a moment. But first of all, let's have a look at the next page, which has which actually has some positive news, because if you actually dig deep in the papers, then you find a positive example for a Big Bang that happened in Japan nearly 100 years ago. And you see here the result, heaps of removed materials. In Japan, the system was converted within a few days. So Big Bang migration is, of course, in principle feasible. However, we now have the issue, that Japan is hardly, the right reference case for Europe. If you look at the homogeneity of the Japanese society and also the Japanese culture versus the European culture. In reality, next page, please. Here in Europe, in order to make the Big Bang happen, we actually have a much bigger task in front of us. First of all, we have hundreds of stakeholders in the EDDP area, which all participate in the migration because they all, are part of the core wagon load system operations. And so basically, they all need to participate in the migration in order to keep the flows within the system. And they need to participate no matter of their differing individual migration business cases. So there are some people which just have very, very old shunting locomotives and they're bigger RUs like Deutsche Bahn, RCA, or SNCF Red. And also these different players have different financing capabilities. And as you know, financing capability in the sector is actually rather scarce due to the fact that margins are very low. Secondly, in order to make the Big Bang happen, all these participants will need to strongly coordinate their activities, and they will need to strictly adhere to a common plan and timing, because the Big Bang will need to happen for each and everyone at the same moment in time. So everyone needs to be ready. That means that we need an early start of the retrofit engineering and testing for locos and for wagons. Thirdly, Big Bang means that we will need to convert all commercially or operationally required assets in the core wagon load system. And they will all need to be migrated or replaced in time. And that irrespective of remaining technical lifetime or technical ability for retrofit, which is quite a substantial demand. For many amongst you who sometimes operate, very old assets, as you have seen for the shunting locomotive specifically. And lastly, we've also seen that screw coupler wagons are operationally not accepted anymore by the core wagon load systems shortly after the Big Bang in order to be able to realize the benefits of the Dac. If we accept screw coupler wagons, then we will need to keep the resources within the system, which means that we will still incur the costs that we want to get rid of. And therefore, we also, need to find a way to deploy the wagons that cannot be retrofitted to the screw coupler wagons. And so that means, in order to make all that happen, first of all, we need adequate public funding and a financing model, that allows everyone to participate in the Big Bang, no matter of the individual migration business case. Secondly, we need a very strong regulatory framework to enhance participation and to ensure that everyone is adhering to the one overall big plan. And lastly, we'll need to find solutions, for the many technical difficulties, that we have indicated in our talk here. What is especially important is that we need to find a way to retrofit these wagons, which is basically minimizing the required labor cost in order to increase the speed. And the tools which we have found so far is the standard pivot pin interface, no welding for duct installation, ideally, standard tools for spring packs, and duct 2 operation after Big Bang. So, thank you very much. I will now hand over to Andreas, I guess.
Unmuting is always helpful. Yes, so we saw a lot, and where we will be in the next decade, I think, is depending not from some people in the migration team, but will depend from all of you, because this year is a whole sector initiative. We have the demand that it has to be non-discriminating. That means not only 3 or 5 companies develop something and the rest has to follow. So whatever you saw here needs detailed input by all of us. And for example, if we come to technology of locomotives, so this can't be answered by a small team of people. So this has to be answered by many people, and many people have to work on that. So, and we have here some guiding principles for the Dac migration and the deployment, and the instruments we need for that. Jens, would you like to jump in here?
No, please go ahead. I have my own slides then at the next bunch here.
Good, because I see you have already your camera switched on. So you see some general principles here on the left-hand side, and the instruments following out of that are focusing mainly on what you saw as separable transports, the mixed network traffic, where we try to solve this challenge with a Big Bang approach, not only with the Dac Ready and pop-up workshop measures, but as well as the pairing strategy. Then we see mainly the workload on this in the end of the migration period. But nevertheless, for the next years, we need to migrate. For the first years, we need to migrate locomotives first, Then we start with the block cranes and make the Big Bang fleet Dac ready. So this is what we will see, but it's a long way to go because we simply don't even have a final design of the coupler head. So as long as this isn't completely outlined, we don't know how heavy a vehicle will be and so on. So this needs far more development here on this part of the project. Next slide, please. And there are still some challenges and uncertainties. And I mentioned already the fleet data, especially about wagons, types and number, but locos are coming closer and closer as the big unknown monster. It turned out that it's not possible to retrofit everything with a hybrid coupler. This is still to be clarified. What we don't know still is the foreseen fleet in use and its productivity in 2030. Then we see that not all who have the old UIC 530 leaflet installation space have the frame stability, and if not all of them, we have to identify which ones. And for those wagons which are not able to be retrofitted, we have to develop, as mentioned already in the one or other slide here before, we have to find additional solutions. Currently, we are investigating an intermodal double pocket wagon, how to increase the frame stability and to create sufficient installation space for the Dac draft gear. And this is what we are currently working on. So, but it's still uncertain. We don't know the number. We don't know the solutions for each and every single wagon. It's as long as it's not clear which technical package will come with the Dac. We don't know the additional operational costs during migration. And of course, this is all being done in an existing workshop of landscape of industry, workshop and workforce. And especially workforce is a challenge, at least in Central Europe. If we see the labor markets there, this will be one of the bigger challenges in the whole migration period. So next steps will be the migration roadmap for the deployment until 2030. A draft is already existing and has to be filled now. We will further continue the consultation of partners all over Europe about the migration roadmap and the Dac itself. And this is creating a huge basis for the development of the migration plan in detail, starting from next year on. So, as mentioned several times, we need all of you. Without you, the migration is not possible. Mainly for three things. First is we have to gather fleet data, and especially numbers and technical details of locomotives. Second is we have to go deeper into operations and workshop capacities. And of course, third, last but not least, is we have to promote altogether smart and short migration, not to extend it longer than needed. The earlier we are through the whole migration process, the better it is for the whole rail freight industry. Next slide, please. Now it's Jens' part to close, and then we continue with the questions.
Many, many thanks to all of you. We hope that has been a little bit enlightening. On closing on Outlook, I only have 2 slides, but let me maybe say before, you see that we have not yet answers for everything. which is completely normal because this is a project like flying to the Mars or so, yeah, or as the D-Day. And this needs a certain preparation and some reflections. Andreas just said that we don't have yet all fleet data, for example, and so on. But what makes us quite confident is that in the last, how long are we working on this now? 1.5 years, 2 years, something like that, yeah? That we have a much better insight into the overall situation and different options, and also thanks to the help of the colleagues here, of Oliver and Christian, and others, that we have the big, because this is the full creativity of the sector that has enriched here this analysis, that we have a much better basis for doing something than in all 100 years before. Johannes Gräber, I know you are on the line, and if you think about our attempts 20 years ago, we have never been so far. We have looked at UIC documents, we have looked at ORA ARI documents in the past, and we were searching for what they have done in planning before. And the only answer that you can see from history is that there was always the big box, here is happening a wonder, and this wonder happened over one Easter weekend at an unknown year. We have not found that this preparation, this analysis had been done so far. That means we certainly have challenges ahead of us, but this is completely normal. The important thing is that we are working on them. And I think this should be the guiding force also for others. And you see, first there is an idea of doing it in a pop-up workshop, then Andreas and colleagues, they go and they realize that, and you see it works. And I think we will have similar effects and others for many more of the challenges that we have ahead of us. And how do we integrate that into a program, and how do we systemate that? And for this, Peter, I would like to have the next slide, please. Thank you very much. So this is the structure of the European Duck Delivery Program, at least the draft, or it's even a decided structure, but not yet completely filled with resources. You have on the left side the Europe's Rail Flagship Project 5. This is in the innovation pillar of Europe's Rail joint undertaking. And the in this part, still also under the cover of Europe's Rail, we have the development until the full deployability of all the technological components. These are the D components that Oliver was mentioning. This is the Dackler, it's the Dackler is a good word, the coupler itself in its final status. And they need to be all done, ready for authorization and so on. The right part where you see the system pillar, I leave that apart for the moment. This is about the general harmonization in the system, especially of operational procedures and stuff like that. And what you see in the middle part is mainly covered at the moment by the works of Andreas and the current work package 3. And these are all the buzzwords you heard. This is about the fleet analysis, loco, wagons, exceptions, and so on. What is not retrofittable? I'm referencing to the question of Patrick Lefebvre in the chat. Capacity, where is precisely the capacity? Where are they? How much is it? Retrofitting plan, talk to the customers. What do we do with them? When can we stop services for maybe 2 weeks and it doesn't hurt them so much? Where are the locations for all these vaccination centers? And we certainly continue with the CBA, because we need to know at more or less every half year how far we progress with the benefits also per individual company and so on, and then the funding and the financing plan, of course. And not to forget, and this is very much impacting the question how far we can and how quickly we can migrate to DAC 5, because also to let you know that the whole sector agreed that DAC 5 is the target status that needs to be achieved as quickly as possible. And the only but is that you have the technology ready and you have the processes ready to install it more or less immediately in the field. And this is why we have this, where you see Commission and ERA, the development of efficient and maybe not so tailor-made, but at least suitable authorization processes. When the colleagues have told you about the quick turnover, the changeover of the coupler head in the vaccination center in the field, that also only works if you have a pre-agreed authorization procedure, which is in the end no authorization procedure. And this is what the flagship project 5 is working on, is a big risk table of all potential wagons. If you mount a middle buffer coupler into it, if the derailment risks and all the stuff is mitigated, if we have tests on that, or maybe some tests from the past and so on. And if we then can describe the risk map as predefined before we start such a migration and such a big bang, then you can assume that the conversion of such a vehicle to a DAC is just a version, maybe not even a version. It can be done within the configuration management of the vehicle. You have to submit that for authorization, but it will be no authorization. It will be just passed through. And if not, we could not do that because 460,000 wagons to reauthorize, it would take, Andreas, until 2050 or so, yeah, maybe plus the locos. And that means it is very much depending on the existence of very efficient testing and non-authorization procedures. And here we have no clear answer yet how far that would work for the Dac 5 stuff. You have seen the hours for mounting that into the wagons. This can be done also in the first part, if it's available, so that you have a Dac 5 ready wagon when you approach the Big Bang. And if we then can switch immediately to something more, this is depending on so much further testing and so much further process availability. Don't forget that at the moment, all the electrical stuff is in the hands of 24 national safety authorities and not at one place in Valenciennes. That means there is still some work to be done. So at the moment, what the colleagues have presented is the assumption that we go to use level 2. And the target is clearly to go as quickly as possible to the use level 5, because the Dac 2 itself is not of a big use in terms of real benefits for the sector. This just to answer, to preempt some of the questions that have come already up here. So this is all what we are tackling with this structure. And on my last page, and then I'm done. Because some say we are illusoric and we are dreamers and this will never work and so on, and you will run us into migration when the whole system will go down the drain and you will kill us and so on. And we say no. We have clearly now in several talks with many stakeholders over the past years said, please be aware that the preconditions for doing a Dac, this goes back to the risks that Oliver was mentioning, which Oliver mentioned, that you have to have the organization ready, you have to have the funding, the financing ready, and so on. This is all in these 6 boxes. So the single Dac system means it has to be the one technology, interoperable, and so on. Proven, second point, tested, because we have to have such a high reliability. Yeah? If we have later on only contact problems, then the best migration will not work, because the trains after starting, they just stop 10 minutes later because there's a defect. This is nothing for migration. Then the proven operational functionality goes hand in hand. So can we really do this as what's promised? But this is all part of a testing procedure, yeah? and demonstrated trains. Then we come to the funding. This is certainly the biggest question that we have here. Will we find the money? And this is a chicken egg problem, because if we have a good plan and we can demonstrate we can do it, the more likely it is that we get the funding, because we are the hope for the climate change in the end. Simpler authorization, I was just mentioning it, and the sound migration plan is what you have seen here, at least from the basics. This is clearly. So these are the preconditions where we say these must be fulfilled before we can really start something, because if not, we would end up and run into a mess. But exactly for this sake, this program is existing, and all colleagues here are helping us. And I can only repeat what Andreas said. We are calling for help. We need, Johannes Gräber said it in the chat, is that the same creativity for locos as for the wagons? I say clearly not yet. We are waiting for that, but I'm certain it will come. I'm absolutely certain it will come. We have some more detailed questions on that. We will take them one by one now, but at least this is the basic message. I've never seen a more reflected situation than that, although I'm also not such a young child in this subject. And with this, we hope that we gave a little bit of a good insight, and many thanks in a big room with our 150 participants. There would be now some applause for you. Let's do it electronically. Thank you very much. And I think, Peter, we can give back to you for handling the questions to us, because we have Slido and all the other stuff. Yeah. So that's from our side. 20 minutes. I think this should be good. Yeah. Good.
Thank you very much, Jens. I think you answered some of the questions already in the talks, but what I'm going to share quickly is we prepared the slides which we got prior to the meeting. So some people asked questions even before this all started, which I will share it quickly here. You should be able to see it now on the screen. Maybe
a little bit larger is also good, yeah.
Yeah, if you could just go through the first few quickly.
And colleagues, we will do this jointly, and we'll quickly decide who can answer best, because what will happen to the wagons where Dac installation is not possible, scrapping or so. Oliver, I mean, you have shown in your charts that there is always a blue bar remaining somewhere, but where they cannot remaining is in the mixed system. There we have to reflect a little bit. Do you want to take this, Oliver? When you unmute yourself, that would also be, as Andreas said, always be helpful.
Yes,
Thank you.
and so I think indeed this is a problem, yeah, you know, which I do not want to, you know, play down. The wagons cannot remain in the core wagon load system because that needs to be a pure play, yeah, and so all of these fleets, they cannot be converted. Will need to find a deployment, you know, in transports that are not part of the core wagon load system. Now, this being said, not all wagon types, you know, are in high demand. For example, in the non-core wagon load system, yeah. So very clearly, for example, scrap, you know, well, it's maybe a bad example, yeah, but you may imagine that certain wagon types, you know, cannot be used outside of the core wagon load system, and for these wagons, the owner then actually have, you know, a problem, yeah.
Which we have to solve by all means of maybe replacement of these wagons, funding in a kind of, you know, and this is, Andreas, maybe some ideas more. We have discussed some in the team.
But at the same time, currently we do not yet have transparency, you know, how many wagons of which type are affected in this way.
Yeah. And in the end, one of the major arguments to gain the highest possible volume of public funding is if we serve the demands of infrastructure, and that means everything that pays into additional capacity, that enabling freight trains to use the digital tailplate for ETCS level 3, for example, that they can run with a moving block system. This would be really helpful. So sooner or later, there will be solutions like this. And if there is not the UIC installation space, for example, or other reasons, we have to check what's possible. And if I mentioned already, intermodal double pocket wagon is a good example. This is a growing market for this type of wagon. It's highly used to bring cargo to the rail away from the road. And this is something where we are currently investigating technical solutions with strengthening the vehicle frame and so on. And I'm sure a significant part, especially of the younger fleet, might be treated like this, and there will be a remaining rest. And then we have to decide. Maybe there will be, for some years, an isolated system for these, let's say, really old vehicles, legacy of the old world. This we have to discuss with mainly with the infrastructure managers. So, but I'm sure we try to leave nobody behind, and to find a solution for all the vehicles which are technically still able to run the next maybe 10 or 20 years. We have to enable them to take somehow the DAC and spring package and so on.
And many thanks. Maybe at this moment, it's also the good moment to pick up the question from Patrick from the chat, because that also refers to the locos. If we have less than 100% retrofittable, Andreas, can you elaborate?
Yes, a bit. Peter, I show my screen for one slide that the one or other may know already, who had been in the one or other meeting on Dac migration, and this shows a bit possible ways. This is not part of today's presentation, but I took it out because I saw the question. On the left-hand side, you see here something similar to what we are intending to have in future as a hybrid couple of locomotives. This is here in use by the Swiss SBB Cargo for a train network that they run as an express network, and here they have a hybrid coupler installed on an older Swiss locomotive. And you see here on the left and right, the buffers are still there. And if you lift this up like this here, you see here the screw coupler below. And if the Scharfenberg head is brought down, then you can use it as a screw coupler locomotive, as a DAC locomotive, or in this case, it's only an automatic coupler. Yeah? So the Scharfenberg coupler can be lifted up and down, and this is the typical hybrid version. But it's heavy to have buffers here. It's more heavy than to have a simple Scharfenberg coupler. So this is a challenge. Here you see in the center two rather modern locomotives which don't have the installation space, and as well they don't have the frame stability for a central buffer coupler, and they have here a special construction. It's a certain front bar. Yeah? Maybe this is a solution for many of the locomotives, but here still you see the weight challenge. Yeah? And the weight challenge is still to be solved, but to go these ways here, we need more locomotives by the manufacturers and by the locomotive keepers about the locomotive fleet. And unless we have this information, we can't develop this here together with the industry and the partners of the sector. On the right-hand side, you see here a low-cost solution for those shunting vehicles which don't leave the station anymore. It's a simple adapter head, but it's not to be used on the long haul. So for the mainline service, this is not possible to use this, but this will assure the survival of many very old shunting locomotives, at least for some years, which are needed in siding services. Imagine you have somewhere in a remote area a siding where you have such a locomotive or such a loco tractor as you see here in this passenger train workshop, and this is maybe 3 times per week in use for a small number of wagons, but without these wagons we will decrease the amount of rail freight in the single wagon network. So we have to offer something like this here, and it's this is not all. You might ask, and for those where are already at the limit of the technically possible weight, remember what we heard from Christian and Oliver about the pairing strategy. Imagine you have a block train, and for the migration period, put one of these pairs into the block train, and if this wagon is, if this train is running normally with a certain type of locomotive, and it has either the Dac or the screw coupler due to weight limitation. Let's say you run it with the Dac locomotive, which is already retrofitted with the simple DAC coupler, not a hybrid one, and suddenly it has to go to the workshop and is being replaced by a screw coupler locomotive. Then you take this wagon pair out of this block train, shunt it around, and then you have a screw coupler on both ends of the train, and this can run with a screw coupler locomotive. This is not easy. This is additional operational effort, costs you time, costs you money, but this might be for a limited period of time a possible solution for locomotives which are running only in separable transports. And as Jens already said, we haven't invented everything now, and not all is already developed and solved, but you can see we have to be creative, we have to combine concepts, we have to use things that are already existing, like this adapter for the shunting locomotives and so on. So there is not a single answer how to treat these challenges with locomotives. But to find answers, we need your data and your cooperation.
Many thanks. I saw already in the chat here, Albanian Railway offering data too. This is exactly the reactions we want to see. We will come back to you later. And I think, Christian, maybe just 30 seconds also on the question of old shunting locomotives and on retrofitability. Maybe this is also the moment for a good refurbishment program funded for greener propulsion traction. Maybe you have a minute on reflection on that.
Yes, thank you, Jens. I think you've already said it. And the figures show this as well. Many of the old shunting locomotives, notably in Eastern Europe, by the way, are actually prepared for automatic couplers. It's a misunderstanding to say that Western European stuff is prepared and Eastern European stuff is not. What we have found out is mostly it's the contrary. So many of the older locomotives in Eastern Europe are actually provided with installation space. The question on the table really is it economically worthwhile to transform many of these old locomotives, especially if you think about the engines and the environmental aspects? Ideally, but this is of course wishful thinking from my side, this would be combined with a massive program in the European Union to replace the old diesel engines by more modern engines, hybrids, battery-driven technology, or anything that is more sustainable than the old diesel stuff. And of course, again, wishful thinking, if that could be the trigger point for getting some additional funding, not only for getting the DAC, but also to decarbonize rail transport further, that would be almost an ideal scenario. Because we're talking about thousands of locomotives that are slightly overaged, to put it very mildly.
And if we talk about, yeah, please. No, are you done?
Yeah.
Okay, thank you. Yeah, exactly. This could become part of a big transformation, modernization part as well. So on the locos, and I might not even exclude that we find locos who are operated and used somewhere in mixed traffic which we cannot retrofit, and then will have a problem, and then we will find a solution. But this is again the challenge and the request to all of you: provide local data. There is a questionnaire, there's a survey going on via the associations, CER, Alpha, UIRR, the AER, the local leasing companies, and so on. And come back individually to especially Andreas if you have any questions, and especially data on that. We are building up that at the moment. It's a tedious thing, but nothing here is not tedious. I see that we have 10 minutes left, and there were some questions still here from the chat and from the Slido. And Peter, I have also seen that you had the PDF questions. Maybe you can take the old Slido questions first, because there was a this was the question on the TSIs and the TSI. Are they somewhere in your list, or is that in the?
They're here. You should see them here now. Regarding Switzerland and
yeah, perfect. Okay.
Part here.
Good. So exactly, there are two questions. The first is TSI regulation, and not to be modified below 7 years. And to be honest, especially for this, we are in fully flexible discussions with the Commission. We have even promised to fill TSIs at each moment where this can happen, and where we have a safe status. That means at the latest, after all the testing done and so on, to start deployment, we have to put something in the TSI. Johannes Gräber has raised his hand. He is part of the system pillar in the Europe's Rail who will tackle and synchronize then the TSI revisions. And we will just do it according to the needs, because that is then something that will help and that will be a burden on the sector. So this is for negotiation. Yeah. And here on Switzerland and DAC ready, I think, Andreas, we have the same challenge here. Switzerland is planning to make DAC ready mandatory. The definition is still a little bit not fuzzy. It's existing, but we also try to do this as soon as possible. When will the EU enforce such a regulation? I mean, the EU can only enforce if all member states have voted that positively in the risk meeting. That means in the committee of the member states. That means the EU is not in a position to say, now you have to prepare your wagons for DAC. That means each amendment of a TSI wagon is also subject to the will and the blessing of all the 24, 27 member states here. And this means that the EU will at that moment say yes to the preparation when the funding, or at least the preconditions, are ready, and we will prepare that for the next possible moment. And that will then also lead to the clarity that the wagons will not be impossible to refurbish, even if they are new built. And Andreas, I think the definition of DAC ready, we are more or less ready with this, isn't it? Yeah.
Yeah, a bit depending from the tech package to be installed, but the technical and the mechanical and pneumatical part is ready.
Perfect, thank you. Then we have a question on, should we maybe first migrate the passenger system? This is the, Peter, if you can just in the order of, yeah, okay. So if passenger trains will be migrated and then freight. I mean, we didn't want to heal the whole world. and I think especially the business cases for passenger trains would be not the same as for the Dac. So this is a completely different game. I mean, you know that already train sets, high-speed regional ones, they have Scharfenberg middle buffer coupler. It's mainly especially for the coaches, and with the buffers, you know, the RSC coaches, ÖBB Railjet and something like that. And they will certainly not migrate to the Dac at the first moment, and they have also normally no interaction. And where we still have locos which are not separated in the fleets, this seems to happen still, then there is still this hybrid solution, or we have to separate the fleets from that. Will the EP light brake be a part of the Dac migration? There will certainly be an EP brake or something which is a control for the brake in the system. We are not completely done with this, but I think this is unexpressly clear. If it will be an EP light, I personally doubt very much, because with this you have not a calculable brake weight that you can really use for longer trains or a little bit higher speed. So it will be something where you can use the brake weight. And so EP light, I personally think rather not, but EP in general, rather yes. Legal measures does the EU Commission have to enforce migration in all member countries at the same time? Could a single member state delay the migration legally? As we just said, I mean, there needs to be a big plan, and the big plan needs to be blessed by all the member states, and they all need to be happy. And then we certainly should have a kind of regulation environment, because if then someone, if it's too voluntary, and someone says that, oh, maybe today I won't do it, but I'm part of a core and wagon load system, but for certain reasons this year I have no special will to do it, then I just go back to the slides of Christian and Oliver and say, how do we want them to migrate the whole system if an essential part does not want to? That means, again, decision making as in the European Union as usual. Yeah. Then, is it feasible to introduce Dac as a standalone action with a non-digitalized railway? I think colleagues help me, but I think we have answered this question, and we said yes for block trains, yes, more or less, but in the overall system rather not. Correct me if I'm wrong. Does mitigation to Dac mean just replacement of the screw clapper, or rather digitizing of rolling and tractive stock fleet? I think this is answered as well. There was a question, can you explain Dac 2, 4, plus 5 and stuff like that? There are different technology levels, and maybe we always use them, but we don't explain them. Dac 2 is something that you have today in Switzerland. This is an automatic coupler mechanically. There is no power connection, no data connection. This is just the classical automatic coupler mechanical, and you save then maximum the coupling time, but you don't have any of these fancy use cases we were presenting in the beginning. Nothing from the D, nothing from digital. And that means the Dac 2 is more or less necessary because as a fallback level and so on, but the nicer one is the 4 plus and the 5, or the 4 and the 5. The 4 is with an automatic coupling, but manual uncoupling, but still the digital other fuzzy gadgets, and the 5 is even with a remote uncoupling. And the sector has clearly said that even the 4 is not of a big use on the long run. The 5 is the target status, because then you can automate everything. And the challenge is to go there. I mean, we have described them already. You need to have it in a reliable and functional way, but I think everybody is clear that Dac 5 is what we achieve overall. Yeah. And why not migrate directly to Dac 5? I think I shortly mentioned it. Look at the de-risking, look at the availability. We will rediscuss that question, I think, many times until 2027, 28. And when technology is perfect at that moment in time, we would say, let's see authorization process. We cannot predict that now. For the moment, we can just say use level of Dac 2, even if the rest is pre-installed, is pretty much more on the safe side. And if we then are quick afterwards, or if, as Patrick Lefebvre has proposed, we have something like a very small box that can do all the testing and the authorization, you print out a small paper and the thing can go on. If that works perfectly, we need your creativity and your help on that. Okay. So are there deeper thoughts in the expected benefits of 4 plus? Any reduction of staff is exactly that, because you don't take away the people on the uncoupling. Are there deeper thoughts at which time of the year, Christmas, summer, autumn, the Big Bang should take place? This question I nicely hand over to the colleagues. Maybe it will in any case take place in one of the enemies of the railway system. Yeah, so either spring or summer or autumn or winter. Well, What do you think, Christian, Oliver? Is it better in summer? Is it depending on the customers? What is the?
Well, I think a quick answer is two aspects. First, you've seen the video about the pop-up workshop. Easy to imagine that it's a little more comfortable to do this in warm temperatures than in cold temperatures. So this speaks in favor of, say, anywhere between spring and fall. And then if you think about the typical traffic seasonalities, you'd come to a point that something around August, while it's hot, maybe a little bit for the pop-up workshop, but there's normally a dump in traffic in the summer month, and that appears to be probably the best period, with a preparation period starting in spring and the whole thing being hopefully mostly completed, at least in the basics, before the fall traffic peak kicks in again.
That means when you come back from the summer holidays, no, you will be certainly part of the helpers then, but if other people come back from the summer holiday, they will see a refurbished system then.
Well, inshallah, as they say. I think it's premature to make any details, but most likely my gut feeling is that it would be something like that.
Perfect. Did we cover already, Andreas, the question from, I think it was Patrick here, on all locomotives reconverted to Dac? I think we touched shortly upon this. And again, yeah, I mean, we have no certainty that we know everything yet already. Safety critical components, are there already definitions available for the Dac? Not to my knowledge. I mean, it's not that safety critical as a wheel set. And especially the representatives of the manufacturers here in the workshop, in the meeting, they will define that within the flagship project 5, and then they're especially important for the question of maintaining and for the ECM later on, yeah, and then for the authorization. This will be part of the authorization procedure. The next is, don't underestimate the effort to make the car D ready. That can only be done in a real workshop during revision. I think you underline what Oliver said, isn't it? Yeah,
I think that's exactly what we say.
Exactly. So that means you have always a trade-off. Yeah, either you want to have everything quickly, then you have to do a lot of things quickly.
But Jens, let's be clear. Making a car Dac ready for D or also mechanical components has this requirement. You cannot start from scratch with a wagon in a pop-up workshop, because already the mounting of the suspension package is not possible and will not be possible in a pop-up workshop. And that's exactly the concept. Whether one can also make the car D ready will depend on many things. Last but not least, the question of how D will exactly look like. It's still in the making as far as I know, and then on how much time it will take. And what is mandatory package and what is maybe something that individual wagon keepers will decide. I think all these things, Jens, still need to be decided, specified and decided in other parts of the projects before going to this point. Of course, it would be desirable to do as much ready stuff as you can, and then be very quick post the Big Bang to really get all this stuff up and working. But the challenge is big.
The challenge will be that, you know, the more D you put in, the more labor you will need in the wagon workshops. You know, I'm sure that labor will be a constraint, you know, that will need to be taken into account. And so if you put it in prior, that means that the timing of the Big Bang will be moved to a later point in time. So in effect, but so I think the best idea is, you know, to make the D as simple and as easy as possible to be mounted, and you know that would actually be the prerequisite, you know, to be very soon after the Big Bang in the operations.
I think that, Andreas, that's the title for the whole development part in the flagship project 5. Make it as easy, retrofittable as possible. Yeah, thank you. Then here, just a statement to start the migration as described. We need a full functional mechanical operatable coupler with the normal operating mode uncoupling functionality from wagon side or from the corner, and this no recoupling functionality. This is in the old version, this is called buffer position. So we have a very competent person here making this statement. And I think Andreas, we can only confirm we have just concluded to work on the operational procedures, and also from the migration point of view, it's clear that you will always have as we have seen in scenarios, you will have a phase where you have, at least for some weeks, month, whatever, only mechanical operations, and we have ATEX zones, and we have sometimes customer sidings, or we have shunting locus where it does absolutely not work, where we don't have power and data. And Andreas, can you confirm here that this is fully valid? Yeah.
Yes, right, completely.
Okay, so you will see as a development for deployment that this is possible. And maybe in a future state when everything is perfect over 10, 15 years, then you can renounce step by step on the mechanics, but this requires really a full, and at the moment I would just say connect your Bluetooth headset to your laptop and tell me how often it bugs, and then you have the answer how much you need the mechanical fallback solution.
Yeah.
Unfortunately, the 6 years maintenance period with a big revision during which such a serious intervention is only possible to be performed is not valid any longer. Yeah, I think this complicates the thing even more because now we are even in the hand of the ECM and the rhythms. But I think, Christian, overall, the 6 years we can still take as an assumption, or?
Well, to make this simple. Of course, we know that there is no legal requirement anymore. Most maintenance schemes still start from the 6 years. Some have prolonged, as is mentioned in the next comment. We have used this for modeling purposes. The main statement is exactly the same as here. Of course, you will want to do the DAC ready and the retrofit, if ever possible, at the occasion of a major maintenance intervention, typically a revision, because otherwise your time losses and all the rest are quite substantial and big. So fully confirm, and
the next as well.
There
The
are
next
500,000
statement as well.
wagons. We had to model something which comes as closely as possible to reality, and we know there are tons of deviations in there, of course, and that has to be done then in national and even company migration plans once the whole process comes to that level.
And you can directly connect it to the next statement from GD Cargo here, which say that even sometimes it's longer.
Yeah, of course. That's I was trying to comment on both statements in one.
Okay, perfect. Yeah. And Andreas, this is then also cutting us on our knees because sometimes we are just, we see that we can maybe not be so quick. Yeah. And this is all part of this big picture, what Andreas calls migration matrix, yeah, where everything is in, where all the knowledge about the vehicles and the related frames and time frames. We also know, especially from Czech Republic, from Poland, from Slovakia, that don't be too quick. But on the other hand, we can also not be too slow. And we will certainly meet somewhere in the middle in the end. Yeah. And if you put wagons to workshops before they enter into the normal revision, when they come back, that means you take them out of service. This goes against the first criterion that Andreas was mentioning in the very beginning. Don't take the wagons off from the customers. Yeah. So this is all part of an optimization planning. Is the RAMS analysis for the DAC available? Not yet. The flagship project 5 is working on that, and the most important is the operators part, which gives the target reliability. I can tell you already now it's something like 99.99997 or something %. It's not yet official or so, but we need to be as reliable as the coupler today, because if not, we produce just more errors. So this is all part of the development in the flagship project 5. Was that the last question, Peter?
Yes, we're through. Just one comment to the audience. Obviously, we're going to collect these answers again. We're going to support them in written form to you and send it out with the recording and the slides in the upcoming days. Ivana and ÖBB is working on the dissemination part of the Accelerate, so you're going to have it all to hand within the next upcoming days, also in written form. But yeah, thank you very much. We are through with the questions. I think we touched on all the questions also from the chat and the 2 polls in Slido. So yeah, Jens, it's your turn to close the session.
Yeah, thanks. I was a little bit quick to get through all these questions, and my last question to you all would be, was that more or less okay? If not, you can resend more detailed question maybe then after the meeting also to us, and then we will include them just in the other questions to be answered. If not, we hopefully showed a little bit where we are. And again, not everything has an answer already today, but we are quite confident. What we need is, Andreas, we need still more participation in WP3 or in the EDP Neo. Maybe, Andreas, you make a small advertisement publicity, yeah?
all of those who are already in the work package 3, you know that we need not the single type of expert. We have representatives there from railway undertakings, infrastructure managers. We have representatives from workshop service providers, wagon rental companies like wagon leasing companies. And so whatever your background is, you are welcome with your expertise. And what we don't like that much is people who are only sitting there and listening and gathering information. What we need is to join the forces and to work together. And working means invest some time, please. And if you are interested and say, I have some relevant knowledge about all these topics tackled here today, welcome. Send either to Jens or to me a short email, and then we launch the procedure to bring you officially into the work package 3 of EDDP, and then we continue. So welcome to all of you, and I'm looking forward, because all of what we hear, what we were listening here today to, was based on the expertise of senior experts from the rail freight sector. So Christian and Oliver and Jens and many unnamed people here who were sitting under a wagon in a workshop. Christian was mentioning it 1 year ago, and in inventing the idea of Dac Ready and pop-up workshop and so on. So and this is only a teamwork, and this is how we can do it, but therefore we need you.
Many thanks, and we can already say to the Albanian Railways who have written this in the chat, we will get in contact with you, and we kindly and happily accept your offer to contribute with the local data. So you have already a new friends in your room, Andreas from Albania this time. This is very good, because we were lacking this information. Yeah, we will come back to you separately. I think, Peter, we have the email address from the invitees. Yeah, that's very good. And Peter, we had how many participants? Do we have a count? It's more than 100, I think, or way more than 100.
Yeah, close to 100.
Close to 100. Many thanks, Peter, for having arranged that technically and supported. Ivana, it's good that you open your video, because you in the end have arranged everything here for us. And this is Ivana from ÖBB. Yeah, I think this will not be the last workshop in this series in function of the insights gained. Maybe we do something like this 2 times a year or so in the future. Yeah, each time we have something to say, and then such a webinar is certainly a good idea, because then we reach to more people. And one day we will also have a big audience, a big auditorium somewhere in Brussels or in I don't know where thousands of people can listen then to all these people here on stage and touch really wagons and couplers and so on. But I think this will be only in 24. From my side, many thanks. Many thanks to the presenters who have done all the work and the analysis. If there are no further questions, I would say have a happy day, work day. Peter, anything else from you, Ivana, from you to say? No?
Just want to emphasize, we did have 80 professionals with us today, which is absolute record, I must say. And also presentations were fantastic. Discussion, conversation, which is very relevant in this moment for this topic, are there. So we are on a good way. And thank you.
Thank
See
you.
you soon. Many of you in a few days, others of you hopefully soon again. Bye bye. Ciao.
Bye.
Thank you.